In this video, I'm going to show you how to do all the extra stuff on the aluminum and copper single replacement lab. So in the second video, I do the actual lab experiment. In this video, I'm going to show you the reaction and go over how to complete the whole lab. So the first thing you're going to do is do a single replacement reaction here. So what you have to do when you do these types of problems is you have to go to table J and look up to see if the metal that's not in the compound is above the metal that is in the compound. In other words, is Al above Cu? Now, obviously for this it is, because here's Al and here's Cu, because if it wasn't, there wouldn't be a reaction and we wouldn't have a lab. So obviously this is going to happen. So Al and Cu are going to trade places. So Cu comes out of the compound and Al goes in. Al is with Cl. Now, when we do the oxidation states for these, what you're going to have to do is remember that chlorine, just like fluorine, is going to be -1. Therefore, when it crisscrosses, so this compound is done for you, so we would set this whole thing equal to 0, and we would figure out that copper is +2 here. And then aluminum is alone, so it's 0, it's a rule. Copper here is alone, so it's 0. This is the only one that's really a question mark, because this is not the actual compound. I'm going to have to crisscross it. Now, aluminum has if you look it up on its oxidation, on the periodic table, the only oxidation state is +3. So that's the only option aluminum has. So when it's in a compound, it's going to be +3. Then I crisscross these and I end up with AlCl3 as a formula. Now, what I would do to fix the fact that they're not equal amounts is I'd go in and balance it. So this would have to be a 2, and then a 3, and then a 3, and then a 2. So there's the balanced equation. And then the last part is going to be for the half reaction. So in order to do that, I identify the two elements that changed. It's always going to be the ones that were elements and then not elements, so Al and copper, because they went from 0 to not 0 and not 0 to 0. That's the quick way to identify these. So there's aluminum. And there's copper. So copper gained 2 electrons. So it was reduced. Aluminum lost 3 electrons. So it was oxidized. So aluminum is going to look like this. I'll use a regular color. And then copper is going to look like this. Now to balance these, we would go in and put in multipliers to make the electrons gained, this number, be the same as the electrons lost. Now in this case, they go to 6, so it's 2 and 3, which does match up with the balancing up here, but that is only because this reaction is very simple. If the reaction was a little bit more complicated, they don't necessarily have to match, because again, we are doing half reactions for a single atom, not for not the true half reactions, which account for the fact that they're multi-atoms. So be aware of that. So that's a little bit, hope that it shouldn't be an issue for you at this point. So now, I'm not going to go into the procedure because I do that in the other video. I'll just mention for the initial observation, the appearance of foil, appearance of solution, and then the final observation. I included pictures of the stuff, of the products after I let them sit overnight so that you could get a better look, but you can also get it out of the video as well. You can see what's happening, and then the temperature change, obviously. I don't need to know the exact number. I just need to know, is it going up or down? So is it getting warmer or colder? That's really it. Now for the back. So for the back, these questions up here are pretty straightforward. Separate sheet of paper, complete sentences, use your own words. Why reactions are spontaneous versus not. What was the brown solid that formed? If you watch the video, I mentioned that. Where'd the aluminum go? I also mentioned that. In the video, I answered question 4. I answered question 5. The post picture shows the answer to question 6. And then number 7, you just need to find 3 metals that would do the same thing as aluminum with copper chloride. If you go to table J, that shouldn't be hard. You should know how to do that. I'll go over one for 8. So for 8, what you're going to do is you're going to figure out the oxidation states, and you've got rules for these. Since these don't have charge, you're going to set them equal to 0. Apply your rules. F is -1, multiply down, we get -3. That means that nitrogen has to be +3. Since there's only one of them, it gets the whole +3. Done. That's all you're doing. You're going to do it for the whole front row. They're all going to be set to 0. You have a rule for most of them. You have a rule for K and O, and A and O. You have a rule for O. You have a rule for H and O. It's just finding one. These are very simple. For this next set, the issue is they have charge. So think of it like this. That's what it really means. So you're going to set it equal to the charge, which we've done before. -2 is the rule for O. I get -6 for O. So that means nitrogen is going to have to be, in this case, to make this math work, +5. There's only one of them. It gets the whole +5. That's all you're doing. And again, you have a rule for everything. You have a rule for O, but not CR. A rule for O, but not P. A rule for H, but not N. And a rule for O, but not S. So that shouldn't be hard. And then for 9, you are going to, this is going to be a lot of work. 9, you're going to be doing these single replacement reactions like I did on the front page. You're going to do all the same work. You are going to, 1, determine if the reaction happens. Okay, so like for this one, K has to be above Mg. If it is, the reaction happens. If it's not above, if the element is not above the metal in the compound, then you would just write no reaction and you'd be done. There'd be nothing else to do, because if there's no reaction, it would be considered non-spontaneous, and therefore there'd be no half reactions or anything like that. If there is a reaction, you're going to do exactly what I did on the very front page. You're going to write the products, balance the equation, write the 2 half reactions. You can put them off to the side or on a separate sheet of paper if you need to, and then balance the 2 half reactions in addition to balancing the regular reaction, and then you do it for all of these and you're done. Just remember that on these first 5, you're using the left side of table J. So metals swap with metals. H or H2 is considered a metal, or H3 for that matter could be swapped. So SR can trade with the H2 here. It could also trade with a single H or a triple H, doesn't matter. And the last one, this is F swapping with Cl, not H, because F is on a separate column, so it can only trade places with Cl. It can't trade places with H because H is on the metal, is considered the metal, or is on the metal side, so we count it or pretend it's a metal, but obviously we know it's really not. So remember, the first 5, you use this column. The last one, it's this column here. If there's no reaction, you write no reaction and you're done. If there is a reaction, then obviously you've got to do the whole thing. And that's everything you need for this lab.